Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hey, a little math in the real world. Safety first in the real world. We're here today at BSK Associates, and we want to talk with branch manager Adam Taronas. Thanks for your time, Adam. I appreciate you being with us today.
Thank you. Thank you for coming.
This place looks amazing. Where are we, and what goes on here? Tell me a little bit about it, and then we'll go take a look at what's happening here.
Sure. Well, we're at BSK Associates. Our company is a geotechnical engineering company, environmental engineering company. We do construction materials testing, special inspection. We've been here since 1972 here in Bakersfield, and what we're going to be looking at today is our materials laboratory, which we test concrete, we test soils, we test asphalt, a lot of the materials that go into the projects that you use every day, the roads, bridges, schools, hospitals.
Okay, so just a super silly question, but I really want to know why. Why do you test all this stuff? Why is that important?
Sure. Yeah, a lot of it has to do with public safety, of course. The materials that are being put into the structures are designed to a certain standard or designed to a certain specification. And so what we are doing is testing those materials to make sure that they meet those specifications and those standards.
Gotcha. And if you didn't have standards, regulations, specifications, you'd have structures all over the place with a different standard of solidity, right? A different standard of building, and you never know how long those things are going to last and what kind of dangers that they could pose, right?
Yeah, a lot of it is driven by the building code, of course. California building code, was developed and enhanced over the years. A lot of the new codes are based on some of the seismic events that have happened in various regions. You may be familiar with Northridge, Loma Prieta, some other earthquakes that have occurred here in California. So we're in a high risk seismic area, and so the building code and the standards are probably to the highest level in the nation. So.
Right. Even Ridgecrest. This is summer, huh?
Exactly.
So what's going on here? We have a couple bathtubs. What's happening here?
So right here, these are some of the samples that we've collected in the field. So these are samples of concrete that have been sampled and brought to our lab. And so they're sitting in a bath of water that's enhanced with some lime. It aids the curing process, and we're testing those samples at regular intervals. So it could be every 3 days, it could be every 7 days, it could be every 21 days. Typically, concrete is designed for a 28-day compressive strength, and so that just means that at 28 days it's got to meet a certain requirement. And we'll show you a little bit about that in the next segment, but that's what you have here with the samples that are here in the tubs.
Okay, what's next? Man, this place got everything.
Yeah. So we test a lot of different materials. We test asphalt. We've got some material here that we use for capping the cylinders.
Okay. So
again, it goes back to the tolerances and the standards for the tests themselves. So they've got to be a certain, they've got to be straight before you can test them. Otherwise, if they're not straight, they could give you some false readings. You're not getting the true strength of the concrete.
Right. So gotcha.
That's a leveling material.
Okay.
We have some water. We use a lot of water in here. We test a lot of soils. A lot of that soil has to be washed. because it tells you, it gives you an idea of what the distribution of the soils are. So we're testing soils, not just concrete, we're testing soils, we're testing asphalts and aggregates. And again, it goes back to some of the specifications that are required for those materials.
Okay.
So,
Okay, good deal.
So Crystal's running a direct shear test, and shear strength is important. It's a soil. In this case, we're running a soil test, but so the strength of materials and the strength of soil in shear is very important, because that's how soils fail in shear. If you look at a retaining wall or an embankment, this is kind of the failure mechanism. So you have a shear zone, or in this case it's a retaining wall, so this is like a cross-sectional view, or an embankment in cross-section, where you might have a slip surface, and in this case a footing, that also fails in shear. So it's very important to know what the strength of the soils are in shear. And soils are a little bit different. They're not like concrete, they're not like steel, which are man-made materials. Soils are very complex. They're highly variable. You could have different compositions of silts, clays, and sands.
Inorganic material.
Inorganic
All kinds of stuff
material.
there, right? Yeah.
There's a lot of unknowns when you're looking at building something. So a lot of what we do is investigation work. So we're drilling, or we're digging test pits to get a better understanding of what's happening underground.
So many different types of soils here too in Kern County that I know of anyway. I know I've lived in a couple different parts of Bakersfield, and we've had clay soils and rocky soils and sandy soils. But what we really want to know is about this testing. So when we come back, we're going to run some tests. That's what the safety glasses are for. We'll run some tests, make sure we can actually do what they say they do here, and we'll find out a little bit how the math works in here. Back at BSK Associates, we want to know, what are these tests that they run in this place? Because there's so much fun stuff around here. Looks kind of exciting, but at the same time, we know there's a little bit of danger to it, which makes it all that more interesting. So we brought Frank in. Frank, thanks for your time, man. Appreciate it.
Thank you for coming, guys.
What do you do? What's going on here? I mean, there's a lot of stuff happening.
Yeah, there's a lot that happens here at BSK. This laboratory is responsible for testing a lot of concrete here in the county, and soil samples as well. I specifically test concrete that is sampled by our field techs.
So we saw some of these in the lime baths over there, right?
Correct.
Okay.
Those are our curing tanks. We have to keep them there incubated for we have a 7-day that we usually do with the set, and a 28. The 28 is what we look at when it comes to the results when we do our breaks.
Gotcha.
So that's the most important part of the test.
Things are breaking.
Yes.
Tell me about that. You have a clipboard here, you got some numbers, and you have a
Yes.
machine looks like it's going to do some damage. So what's happening?
Definitely does do some damage. This is why we do a lot of safety precautions, because safety is a priority here with this lab.
Sure.
But here are some numbers. So this is roughly what we do here. We record the specified break and the strength here. So 4,000 is what these were required. You have 3,500 and so forth.
And what do those numbers represent? PSI or something like that?
PSI, exactly.
All right.
So PSI is determined here with this machine.
Okay, and
this
that's
is
pounds per square inch. So that's how much pressure is going on.
correct.
There, right? Okay, got
This is a compression machine that we use. We have our setup for 4x8s,
Okay.
and then we have a different setup for 6x12s. Today, unfortunately, we won't be doing that.
right.
Those are a little bit more, higher on PSI. So
Sure.
we just wanted to play it safe. But other than that, everything is controlled here. We do we do have another shield here. This is where I control the machine itself, which I will always be standing by, and everybody will be safely away.
Right.
Other than that, here are some tests that we did earlier.
Okay, and
So-
and they broke, right? So
Yes,
tell us what we're
exactly.
looking at when they break, what you look at specifically to know if this piece of material met the specifications or did not meet the specifications, right?
Okay, yeah, no, definitely. So these did meet specifications
Okay.
earlier today. They surpassed the 3,500 specification that was required for the structural building.
Okay.
So these broke about 5,500. So clearly,
Wow.
2,000 over the 3,500.
Right, but that's kind of fun. Once they meet that specification, like, we're still gonna break it. We're
Exactly.
still gonna get it.
Yeah.
We're just gonna see how much it can take.
Thankfully, this has a certain limit,
Okay.
which is about 10,000.
Okay.
So we're never gonna really surpass that. If we do, we, take other precautions and
And you
test
say it
differently.
gets an A+++, and go ahead, it passes. Yeah,
Yes.
there you go.
So here with this brake is a Type 2. It is what we call a conical brake. This is why it kind of shapes like a cone, as you can tell.
Okay.
And then this would only mean that everything within the mixed design is evenly proportioned, creating such a brake like this.
Okay.
And allowing it to get such a high breakage,
And that's a good thing, right?
which is a good thing.
Okay,
yes.
so those are a good thing. Good
But
results.
having a different type does not mean it's a bad thing either. So
Okay.
here we have a Type 3. As you can tell, the bottom of the base was beginning, it did, crack off, not allowing it to get a complete base like this. So this is what distinguishes a Type 2 and a Type 3. Does not mean that it failed, but that's just how it broke.
Okay.
And so here, as you can tell, it kind of went vertically. I could show you a little bit better here. So see how the crack goes all the way vertically down? We
Yeah.
have some that go as well to the side of it, causing it to break like that.
Right.
And this held at the base. So
Just
like
just
I
some
said,
data, right?
just
some
some
input,
data, yeah.
And you have to know when it breaks how it broke and all that fun stuff.
Exactly.
Anything different here on this one?
So here is what could possibly be another 3. See how they're almost matching here at the
Yeah.
bottom of the bases? The bases were getting weak, causing it to break like this. We do have some conical here, but having the fact that this broke at the edge like this, it is considered a Type 3.
Right, gotcha. Okay, so we want to see you do this. I'm going to put in my ear protection, right?
All
We're all
right.
going to be nice and safe, and let's see what kind of break we get on one of these new ones.
Perfect. All right, so safety is of the most concern. I have to have my ear protection, eye protection, and then my gloves. You never know. So here's what a 4x8 looks like. As they come received, you'll have some uneven topping. So I have to cut it with a masonry saw so I can get perfect plainness. This allowing me to place this evenly on our neoprene pads. So I put this here, put the top pad, make sure this one's clear. Usually we have a rag nearby. You want to make sure the top is clear of debris. You're going to place the cap here, and then this wrap. This wrap allows more protection in case, for whatever reason, shrapnel is shot out beyond our safety measures here. So I'm gonna put gonna make sure my pulley is locked here. This lever has to go completely to full in advance to allow me to make sure that this 4x8 is centered. Now I do this in increments so I can get a complete center displacement here. So I'll slow down here, make sure it's all the way back on hold so that way my fingers don't get pinched. I'll view it here, and looks like we're about centered there. Once I know I'm centered, put the shield up, put this lever all the way forward. Now you'll see some readings here. Once this starts to go down, I pull the lever back and open the valve. I want to make sure this is centered here, so adjust the valve just a little bit more. And there we go. So we're just about centered there. So that'll basically allow me to interpret that there is centered displacement, well, a centered force on the 4x8. So I know that, there we go. It's a little tricky, that it's gonna break evenly. We don't want something that is broken prematurely on its side, so keeping it centered is always a good rule. All right. There we go. So these two little dots there next to the center indicate that it is fully, equally forced on that 4x8. So once this starts to give out, it'll go to the left. Still, I can still control it now, but once I can't control it and it goes to the left, you know the cylinder is about to give out. Right there. There we go. So I locked my valve here, pulled the lever all the way back, making sure that this is no longer exerting force. Put my shield down. So here, remove this. Now, with this type of brake, this is a type 2. As you can see, I only have this much off. So I still have a solid base. As you can see at that angle, it's almost conical. So that would be considered a type 2. Now with the numbers here provided, the PSI strength is 4,331. What we needed was 3,000. This has definitely surpassed the required specified strength. So this would be a pass test.
A success.
Yeah, success.
Yeah, all right. The BSK party begins. Hey, when you're checking out math in the real world, there is no better place to be than outside. This is the real world. We want to know a little bit more about how all that testing that was done in the lab goes into making a beautiful place just like this here in Bakersfield. So Adam, tell me a little bit about, we know why we test, right? But how does that relate to this amazingly beautiful spot we have here?
Sure. Yeah, well, you may be able to recognize this is Mill Creek Park. We're still in the city of Bakersfield. And Mill Creek Park was a project that was put forth by the city of Bakersfield. And as I mentioned, there's a lot that goes into these projects. There's a lot of planning, there's a lot of engineering, and of course there's a lot of testing. So this is an example of a civil engineering project that a company like BSK gets involved with. Like I said, both on the engineering side and on the testing and inspection side.
Gotcha. So it looks just like a natural transition from the grass to the cement to the bridge, but this is a master planned area. It has to be for it to be sustainable, right?
Exactly. All of this that you see here is part of the plan. There probably isn't one thing here that is unintentional. You know, the trees here, some of them are big, some of them are small. You can tell the difference from what's been here a long time and what's new if you look closely. But it all works and it all works together, and it's all a part of the master plan and making Mill Creek a better place.
Right. So if a young person sees this, sees your lab, gets really excited about, gosh, I want to be able to not only use some math but make a difference in the community, how do they start in your profession? What can they do now as a young person?
Well, certainly, you know, getting good grades, studying, working hard, getting involved with different clubs, organizations. Get into a place where you're interacting with other people, because engineering is not a solo sport. There's a lot of different team members, there's a lot of different personalities, and getting to know other people and how to interact with people and how to present, how to talk to people. Those are important parts of being a civil engineer, because eventually you'll have to be able to explain your design or your vision of what this could be.
Right. Oh man, so we know the math is important, but gosh, so many other parts that go with it. We really appreciate your time today. I know I learned a lot, right? I felt awfully safe in the lab and feel like it's, gosh, just part of nature out here. We want to go ahead and make sure you get the famous Do the Math tile. Maybe they can go up in the lab there somewhere.
That's awesome.
Just for your time. And gosh, thanks again, man. I just learned a whole bunch.
Great, thank you.
An amazingly beautiful place out here, and we got to learn a little bit more about the background to it all, because it's not just, it doesn't just happen. There's a lot of planning that goes on.